So the last section we're going to look at this week is the law of cosines. So let's take a look at this problem. I'm not going to solve it right now. I just want to look at it. And let's pretend like we tried to do this with law of sines. So I've given you 3 pieces of information, just like always. 2 sides and an angle. But to use law of sines, we have to use 2 rows in that table. If I pick the first 2 rows, how many things are unknown if I pick the first 2 rows? Okay, 2. That's no good. You can't have 2 things unknown. When you set up a proportion, you can have 1 thing unknown, right? In your proportion, 3 out of 4 spots have to be numbers. The 4th spot can be a variable. Okay, so forget it. Let's not try the first 2 rows. Let's try the 2nd and the 3rd row. If you tried to use those 2 to set up your proportion, how many things are unknown? Oh, Megan? 2. So that's not going to work again. So let's try the last possibility. We're going to try to use the first row and the last row. If you use the first and the last to set up a proportion, how many things are unknown there? Yep, 2. So no matter which 2 rows you pick, you're going to have a problem. And that's because you don't have a row with everything in it. Okay? So this is a problem that you cannot do with law of sines because you'd have 2 variables going at the same time. So law of cosines is used for 2 different cases. Okay? This is one of them up above, and the other one is side, side, side. Yeah, I'm not going to make a table right now, but just imagine if you had side, side, side. You'd have a column with everything in it. To use law of sines, you need a row with everything in it. So on the test, the first step that you're going to have to decide when you're given information is, all right, should I try the law of sines or should I use the law of cosines? So I suggested, but this is up to you, on a reference sheet, I would list all the types of problems you can do for law of sines and law of cosines. So we've got angle, angle, side, angle, side, angle, and the one we don't like, side, side, angle. Maybe you don't like them all. And then law of cosines, we've got these 2. Side, angle, side, 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 side. Those are the only 5 types we ever come across. Okay? If you're saying, well, how come we don't do angle, angle, angle? We don't do angle, angle, angle because let's say I said to you, I'm thinking of a triangle and it's equilateral. The angles are 60, 60, 60. I just told you all the angles. How big are all the sides? You don't know.
As long as they're all the same, they can work no matter what number it is.
Yeah, they could be 2, 2, and 2, or 12, 12, and 12. You don't have a side for a scale. Every one of these cases has to have at least 1 S so that you have a scale. Sometimes 2 S's, sometimes 3. But you got to have at least 1. So on the left, that's a side angle side problem. You've got 2 sides, and this time the angle that you know is in between the 2 sides. It's where they meet. If the angle was somewhere else, then we're going back to what we did yesterday. Then it could be side, side, angle. But this is side, angle, side. Okay? And then the other case is side, side, side. That's where you're given all the sides. So in the formula that I'm going to give you for law of cosines, it's going to use the same naming system that we're used to. A's, B's, and C's are sides, and the angles are alpha, beta, and gamma. Now, this law, kind of like law of sines, it has 3 parts to it, right? Like law of sines has 3 fractions. This has 3 equations. Right? So it's like three different equations. Once you see the first one, you're going to notice a pattern. Each equation has the same pattern. Right? So let's start with this one. The different equations can all start out with different letters. You can start with c squared, b squared, or a squared. I'm just going to show you the c squared right now. C squared equals a squared plus b squared. What's that look like? Yeah, all right. And if we were going to go through the proof of this formula, which we don't do the proof of law of cosines because it involves trig identities, and we haven't learned those yet. So the proof wouldn't make sense. But if we were, part of the proof, it uses the Pythagorean theorem. Okay? So, but we know that Pythagorean theorem can only be used with a 90-degree angle. So what we have is this adjustment. Okay, it's like the Pythagorean theorem adjusted. Right? So you can kind of think of it like that. And the adjustment is you have to subtract something. Okay? And here's what you have to subtract. You have to subtract 2 times the letters you have right here. So in this case, it's an A and a B. Times the cosine of the angle across from the letter you started with. So C is always across from angle gamma. Right? So I'm just going to read it kind of generically. One side squared equals the sum of the other 2 minus twice the other 2 that you just wrote times the cosine of the angle across from what you started with. As long as you think of it like that, you can start with c squared, b squared, or a squared. Okay, so now we'll look at the b squared version. Okay. Anyone think they can tell me what's going to come after the equal sign here? Okay.
A squared plus c squared.
Yep. A squared plus c squared minus, and then what's going to be in the parentheses? Minus, yep.
2ac cosine gamma.
So we got 2ac, yep, cosine. And now what's the name of the angle across from the letter we started with? Beta. So 2ac cosine beta. Right? That's not a different formula than the one above it. You're just playing like playing a game with what you're calling things. You want to call it A, you want to call it B. I mean, I could write x squared equals y squared plus z squared minus 2yz. You can use whatever letters you want. Right? So sometimes I don't even like showing it 3 different ways like this because it's all the same thing. I don't want you to think it's 3 different formulas.
So they're basically just based on what numbers you have.
Yeah. Yeah. And it's important to understand the idea of a pattern because when we do a word problem, they may not have any A, B's, and C's at all. Right? You just have to understand the concept. Oh, one side squared equals the sum of the other 2 squared, and then go from there. So what would be after A squared? B squared? B squared plus C squared. Yeah. Minus
2bc.
So minus 2 times the sides you just used right next to it.
Cosine of alpha.
Times the cosine of the angle across from the side you started with. Cosine alpha. Yep. Okay, and that's the law of cosines. Okay, so on a test, you might have a problem like this, and I'll just say solve it. And if you're saying, well, what side is A, what side is B, and what side is C? I don't know. Whatever you want. So make this side A, make this side B, make the top side C if you want. It doesn't matter. Okay? You can label these sides any way you want. Just follow the pattern, and you'll be okay. Okay. Any questions on the formula? So as far as new information today, that's it. That's the only thing that's new. Now we're just going to try 3 problems. We'll do one side angle side, one side side side, and then a word problem. Okay, this is the same problem that you had in your notes when we started. And I said, let's just look at it and see what happens. All right, so I could sketch it. I don't really think I need to here. I think when you have a word problem, you really need to sketch it. But if we want to sketch this, A across from alpha, B across from beta, C across from gamma. For some people, the sketch might make it easier to figure out what kind of problem it is. So, what kind of triangle is this one? Based on like the A's and S letters. It is side angle side. You know 2 sides and you know an angle between them. The other way that I know it's side angle side is if I look at the table, I don't have a full row, right? So I know it's not one of the law of sines problems. And I know that with law of cosines, the only 2 types are side angle side and side side side. Well, this is not side side side. I don't know all the sides. So the only other type it can be, if it has to be law of cosines, is SAS. Okay, can we use Pythagorean theorem to get C?
Yeah.
No? Why not?
No, I said yes.
You said yes. How come?
Because like when you go back up and you just plug in 2 and 3, and then plug in the 2 AB cosine gamma, then you can get C.
So is that Pythagorean theorem or law of cosines?
No, law of cosines.
Law of cosines, right? You can't use regular Pythagorean theorem. Just C squared equals A squared plus B squared. That's not going to work. If you do that, you're assuming that's 90. It's not. It's 60. But we can use the law of cosines. So let's just look at it. If you know the pattern, you should be able to figure out, okay, one side squared equals the sum of the other 2. If you don't know the pattern yet, go back and look at every possible way you can arrange the formula with letters. And are we using the top one, the middle one, or the bottom one if we want to solve for C? Yep. Yeah, the top one. You can't solve for alpha and beta yet. It's impossible. Let's say you wanted to. You say, okay, I'm going to use this one. Well, all right, you're trying to solve for alpha, so you're missing alpha. That's one thing. This formula also has a C in it. Well, you're missing C. Okay, so with side angle side, find the missing side first. You have to. Because we're going to need that missing side to get the other 2 angles. So, what does that mean? If I'm going to use this side to find alpha and beta, what does that mean could happen? Jason? What does that mean? We're going to have to use C to find alpha and beta. So what does that mean could happen?
I don't know what that means could happen. I just know you have to put C squared first.
So yeah, we're gonna solve for C, but then we're gonna use that. What do I always say about stuff like that? Yep.
It'd be like 2 answers.
No, with law of cosines, you'll never get 2 answers. You only get 2 answers with the thing we did yesterday. So you're never gonna have to worry about 2 answers. But I'm more concerned about using what I'm gonna calculate to find other things because
It could be wrong.
it could be wrong. So what that means is if you get C wrong, alpha and beta will also be wrong. Just the way it works. So just go through very carefully when you find C. So let's plug everything into the first one. The first time through, I'll write every step out. after that, we'll kind of shorten it up and do a couple steps at the same time. So c squared, a squared, plus b squared, minus 2ab, cosine of the angle across from the letter I started with, gamma. Okay. Any questions on setting that up? All right, now let's simplify it. Now, I said simplify because this isn't really solving an equation. The letter is pretty much already by itself. So you're not really trying to get the letter alone. I mean, yeah, you're going to have to take a square root at the very end, but that's the only thing you have to do to get the letter alone. Everything else is already on the other side for you, which is good. All right, so if we do this out, Alyssa, what's 2 squared? 4. And Andrew, 3 squared? 9. Minus, Max, what's 2 times 2 times 3? 12. Cosine 60. Now, follow PEMDAS. You got to make sure we do things correctly. I have addition, subtraction, and multiplication. Which one should I do next? Yep, do the multiplication. Minus 12 times, and actually to do the multiplication, I need to figure out what the cosine of 60 is. If you type that in on your calculator, you will get 1/2. Okay. If you want to check it, I just know that one because it's a nice answer because 60 is a multiple of 30. That's why I know that one. Okay, now I can do the multiplication because I know it's cosine of 60 is 1/2. So 4 plus 9 minus, Brianna, what's 12 times 1/2? 6. Now I do all my addition and subtraction just in order from left to right. So Sebastian, what's 4 plus 9?
13.
13. And then Courtney, 13 minus 6? 7. Now my last step, I do have to get rid of that exponent of 2. So Cal, how do I undo squaring something?
You get the square root of it.
Right. Squaring is a function. It's not arithmetic. So the only way to get rid of the squaring function is a function which is the opposite. And we call that square root. Square root, square root. And we are going to round this off. Okay, so the square root of 7 is 2 point something. 2.646. And that's C. So the way I did it, I mean, I really wrote out every single step. You know, I mean, I probably could have just done 4 plus 9 minus 6 all in one step and got 7. But first time through, I'm just trying to show you every step. Okay, so 2.646. All right, let's add that information to my picture and look at what I have now. So remember what we had to start with. We had side angle side. 2.646. What other kind of triangle is it now? Since you figured out another side. It's more than side angle side now. Yeah.
Side, side, side.
It is. It's now also side, side, side. You could look at it that way. It's also one other type. So side angle side is what we started with.
Yeah.
So yeah, it's now side angles. So it's still side angle side. Next.
Side, side.
It is side, side angle. These two, you use law of cosines. This one is law of sines. So technically, if I'm careful, I could finish this problem with law of sines. But what don't I like about side, side angle? It's law of sines, but it's the what?
You can do the 2.
Yeah.
Or no.
It's the case where you have to check for the two solutions and all that stuff. We know it's not no solution because I already have some solutions happening, okay? But it could turn out to be the two or the one solution, and I can tell you with law of cosines, it's always one solution. So the tricky thing is if you use law of sines, you'd have to figure out which answer it is. It's either the one you get, or it could be the one you get when you subtract from 180, but it wouldn't be both. Right? So we don't want to have to deal with that two solution stuff. So we're gonna get rid of that. We're gonna treat this problem just like it was law of sines still. So don't finish this off with law of sines. Okay, that'll mess you up. Just continue with law of cosines from here. Now, I wrote that you had to find the side first. You can do whatever you want now. You can do alpha or you can do beta. If you go back and look at your law, to find alpha, you're going to need B's and C's and A's. Yep, we got them all. To find beta, you're going to need A's and C's and B's. Yeah, we got them all. So we could do either one. It doesn't matter. So let's do alpha. So alpha starts out a squared equals b squared plus c squared. So I'm going to do a couple of these steps as I go this time. A squared is 4. Equals b squared is 9 plus c squared. Now, I could take 2.646 and square it, but I don't need to do that. I already know what 2.646 squared is. What is it? 7. I just did that in the previous step. C squared was equal to 7. So just use that information. Plus, if you take 2.646 and square it, you're going to get like 6.9999. You're not going to get exactly 7. Right? So c squared is 7. So a squared, b squared, c squared. Minus, what are the next two letters I need? So remember, we're finding alpha, so look at the version that has alpha in it. Can you say it again? Maybe I heard you wrong.
B and C.
B and C. Right? Two letters there are B and C. So 3 and 2.646. This is where you are now using something you calculated. So if it's wrong, then alpha is going to be wrong too. So a squared, b squared, c squared, minus 2bc, cosine of alpha. That's what we're trying to find. Now, this is kind of the opposite of what we just did. What we did before, the letter was pretty much by itself the whole time. We only have to do one thing at the end to get rid of that exponent of 2. This, the letter is not by itself at all. Right? Almost everything is on the side with the letter, so we got to get everything away from the letter. So let's simplify what we can. Okay. We're solving an equation now. Okay. So when you solve an equation, the first thing you want to do is combine like terms. We weren't really solving an equation up here. We were doing arithmetic. That's different than solving an equation. So 9 and 7, those are like terms, so you can combine them. Now, minus. We can also do this out right here. We can combine those like terms. 2 times 3 times 2.646. Brandon, what's 2 times 3?
6.
And we've got 6 times 2.646. So 15.876. times cosine alpha. Okay, so I combined like terms. Anybody know what I would do next here? There's three things I need to get away from the alpha by the time I'm done. You gotta be careful here. You're solving an equation.
16 minus 15 minus 86.
So what if you had this? That equation that I just wrote is pretty much exactly the same thing you have up above. Can you do 16 minus 15?
No.
No, those are not like terms. The 15 is multiplied by something with a variable. So what would be your next step in this equation? And whatever you would do here, you're going to do to the one up above.
Just divide by 16.
You divide by 16 here?
Yeah.
I mean, you could, but that's good. I think that might make it harder.
Divide by x.
No.
Subtract 16.
Subtract 16. Yeah. So when you're solving an equation, you always do all your adding and subtracting that you can first. Right? So move the 16 to the other side. Minus 16, minus 16. That's gone. 4 minus 16 gives me negative 12. Okay, so now there's only two things next to alpha that we don't want. What you have right there is basically like this. You have a number equals a number times something you don't know, times a variable. So, anyone think they can tell me now what my my next step is? Yep, Isaiah?
What do we do? Inverse cosine?
So remember, when you're solving an equation, you always want to get rid of the things that are farthest away from the variable first. Think of the variable as like protecting what's near it. The variable can protect the cosine. We want to divide by negative 15. Okay, that would be your next step in this equation. Divide each side by negative 15. Oh, we're getting to the inverse cosine. That's going to come up. But that's always the last thing. I will. All right, so negative 15, 876. Divide by negative 15, 876. I'm not even going to do this out. Okay, I'm just going to cancel the negatives. And I'm just going to leave it as 12 divided by 15.876. Why? Because I don't really care what 12 divided by 15.876 is. All I care about is the final answer. What happens on the right-hand side? Okay. The 15s and in the next step. What else cancels with the 15? The negative. So you could either say the negative 15 cancels or the 15 and the negative both cancel out. Now we're at the last step, which you started to say, which was to do what?
The inverse cosine.
Right. So now we're going to take the inverse cosine. And inverse cosine, those cancel out. Type in what's on the left, and that is our answer for alpha. Inverse cosine of 12 over 15.876. Now, before you type it in, look at your fraction right there. If that fraction has a bigger number in the top, don't even bother typing it in. You did something wrong. The bigger number always has to be in the bottom. Always. So if the bigger number is in the top, you can type it in. Your calculator is just going to say error. And I'm telling you right now, I'm not going to give you a cosine problem that ever comes out to error. Ever. Okay. So make sure the bigger number is always in the bottom. Okay, so second, inverse cosine, 12 divided by 15.876. Okay, so we get an angle that's going to round up to 40.900 if we want to keep it accurate. Okay, so we got that. And now, now that I have alpha and gamma, what could I do with them to find beta? Yeah, I can just add them up and subtract from 180. So that's going to be 100.9. So 180 minus 100.9. So 79.100. Again, if I'm keeping that accuracy. Any questions on that? So side angle side pretty much combines everything you would ever have to do in a law of cosines problem. Solving for a side and solving for an angle. When you do a side-side-side problem, you never have to solve for a side. You're always solving for an angle. So, which out of those three formulas, which version of the law of cosines should I use, would I have to use first? Yeah?
Side, side, side.
Okay, so it is a side-side-side, so I'm asking which alpha, beta, or gamma do I have to find first? Yeah. Any of them, doesn't matter. When you have side-side-side, you can find any one of them first. So, find any one of them you want. How many times are you going to have to do law of cosines at a minimum here? Twice. You have to do it at least twice. Unless, can anybody think of a case where you would only have to do it once? It would have to be special, but it could happen. Yeah.
If all the sides are the same.
Yeah. If all the sides are the same, then, well actually you wouldn't even have to do law of cosines. If all the sides are the same, what are all the angles?
Same.
They're all 60.
I'll bet.
But, you're kind of on the right track if you had two sides the same. Right? If you said this was 4, and this was 6, then if those were all the same, then, or 4, 4, and 6, then all I'd have to do is find one of the sides, 4, and then I'd automatically know that angle, I'd know that angle, and then the last one, well, just add them up and subtract from 180. So, most of the time though, I'm not going to give you an isosceles triangle. I'm going to give you a scalene, which means you're going to have to do law of cosines twice. So, anybody pick an angle and tell me which one you want to find first. Get 3 choices and you can't go wrong.
Alpha.
Alpha. So, let's find alpha. How does the law of cosines start when I want to find alpha? What's the first thing? Yeah.
A squared.
All right, let me start with that. A squared equals, and then what did you say?
Well, then it would be equals b squared plus c squared.
All right, so b squared plus c squared minus 2 times b times c. Okay, so we're going to do all that at once. 2 times b is how much? 6 times 6. 36. So minus 2bc cosine alpha. Abby, what's my next step here?
Solve it, I don't know, what do you mean?
So like if I gotta simplify some stuff on the right hand side. So what's the next thing I could combine?
The 36 and negative 36 cancel out.
Well, remember this, it's almost like this. With the 36 and 36 cancel there?
No.
No, because one of them's an X, one of them doesn't. So they're not like terms. But do you see anything else you could do?
Add the 9 and 36.
Yeah, add the 9 and the 36. So we can take care of that. So that's going to give me 45. Minus 36 cosine alpha. Now I've got 3 steps left. How about Megan? Can you tell me my next step?
Subtract the 45.
Yep. Subtract the 45. Now that's simple enough. I do want to do 16 minus 45 and just get that out of the way. 16 minus 45 is negative 29. Okay. 2 steps. But Justin, what's my second to last step?
Divide both sides by negative 36.
Perfect. Divide by negative 36. Negative 36. Those are all gone. Negatives are also gone there. And look, the bigger number is in the bottom. That should always happen. It should just happen on its own. Okay. So 29 over 36 equals cosine alpha. And Alex, what's my last step?
Inverse cosine.
There you go. Inverse cosine. And inverse cosine. That's gone. Type in the inverse cosine of 29 over 36, and we will know what alpha is. So inverse cosine 29 over 36. So 36.336. And that's alpha. Now, what I can tell from that is beta is going to be a little smaller, and gamma is going to be the biggest. We would have to find either beta or gamma next. Then, once we have that, we could add it up and subtract from 180. Okay? So you'd have to go through this one more time. But you can see you can shorten it up quite a bit if you do some of the steps as you go versus the first time I did it. I mean, I wrote out like 7 different steps. Okay, we could have even shortened this up a little bit. I think maybe we've got like 5 steps there. We could probably get that down to 4 steps. So any question on how you finish that up? Okay, so law of cosines, when you have all the sides, not as much variation because you're doing exactly the same thing twice. Side angle side, you're not. One time you're finding a side, one time you're finding an angle. So you're doing one of each. All right, so last problem we'll look at is a word problem. So this problem is going to involve finding the distance between 2 houses. Bless you. So this could be the kind of situation where maybe, let's just say, it doesn't even have to be houses. You've got like a canyon, all right, in front of you. There's this huge canyon. And on one side of the canyon, you see an object, and on the other side. So maybe you're trying to measure the width of the canyon. Okay? Maybe it's like thousands and thousands of feet wide, so you can't just take a tape measure and measure it. So you want to figure out how far apart these two things are. So, for our problem, there are going to be 2 houses. And again, pretend like there's something between the houses that's preventing you from directly measuring it. Canyon, river, whatever. And what the surveyor does is they stand in one spot, They point their laser at what they're trying to measure, and then they turn it, keeping it exactly still, just rotate it, and point it at the other thing they're measuring. And the angle between the two objects they're measuring is 70 degrees. I'm going to have a picture that kind of helps out a little bit. Now, what the surveyor can do is they can walk to each house. You know, from where they're standing to the house, you know, they'll walk on one side of the river, and then there's like maybe a little bridge over the river or whatever, and then they can walk from where they're standing on the bridge over to the other house. So the surveyor measures the distance directly from where they're standing to each house. Honestly, maybe they don't even have to walk it. They can probably just point a laser at it, and it'll tell them exactly how far away it is, like some kind of rangefinder. Right. So, surveyor measures those two distances, and the distance from where they're standing to the first house is 50 feet, and from where they're standing to the second house is 70 feet. So what we really have now are two sides, right? And we have an angle. Okay, so our goal is going to be to figure out how far apart the two houses are. So, I said to you that there's some reason why the surveyor can't measure between the two houses. Okay. In our case, this is the reason. Between the two houses, there are giant crabs, that's dangerous, poisonous tree frogs, and a bunny. So all those things together makes it very challenging. It's the Easter bunny, but Easter bunny can be dangerous. We don't know. It's kind of smiling, but
It's waving.
it's waving. It's trying to lure you in. That's what it's doing.
It doesn't have a nose, therefore you know it's dangerous.
Yeah. So that is what's preventing us from measuring the distance between the two houses.
So we don't have to do it.
Yeah.
Well, we don't have to walk it, but we still gotta do it.
Oh.
Yeah, we don't have to walk between them. Right. Now,
What about hockey?
for the surveyor,
Do you do hockey?
okay, I've got a picture of the little surveyor. I looked quick for a surveyor. They don't have surveyors, but they had this guy. That's it's a German soldier. So pretend like he's a surveyor. That's what we got. All right. So our surveyor measured those two distances. Okay. And again, this bunny. I mean, why would you want to mess with this bunny? It's like the size of two houses. You don't want to go near that thing. The thing's huge. Look at the crab. The crab could like sit on top of the house. So it's very dangerous.
Yo, crabs.
So it says the distance from where the surveyor is standing to house A is 50 feet, and from house B, it's 70 feet. So this is 50, and the other one is 70. What did it say that the angle was between the two houses? 70? Just coincidence, it's the same. And what we're trying to find is that, the distance between the two houses. So, side, angle, side. Law of cosines. Okay, let's call this side x. So, remember that the original idea, okay? One side squared equals the sum of the other two. We don't have a, b's, and c's for sides anymore. So I'm going to start with x squared. What would be the next thing after x squared?
Squared.
50 squared, yeah. Plus 70 squared. Minus, minus 2. $50 times 70. So 250, 70 times the cosine of the angle across from the side you started with, 70. Now, this is more like the first type. Okay? The letter is pretty much already by itself. So we're just going to simplify all the arithmetic on the right using PEMDAS. You do not have to move anything left to right here. Alright, let's do it again. Bless you. What is 50 squared? 2,500. Yep. And 70 squared?
1,900. Wait, no.
Just 7 squared with 2 zeros.
Just 14,000.
What's 7 squared? 49, and then yeah, 4,900. 2 times 50 times 70. 2 times 50 is 100. What's 100 times 70? 7,000. Cosine 70. Now, I mean, you can use a calculator for all that, but because those are nicer numbers, we can do some of it. What's 2,500 and 4,900?
7,000.
Yep, 7,400. Minus 7,000, cosine 70. Now, 2 things here, subtraction, multiplication. Which one should I do first?
Subtraction.
Multiplication. Okay, so remember, PEMDAS, you always do your multiplication first. So let's do 7,000 times cosine 70. We get 2,394.1. 2,000, what was it? 394.1. Now do the subtraction, and at the same time, what's the last thing I need to do to get the x by itself? Yeah, I'm going to do the square root and the subtraction at the same time. Okay, so square root of 7,400 minus 2394.1. Okay, so the distance between the 2 houses is about 70.6 feet. Okay, so you can see on that one we really compressed a lot of the steps, so we really only had 4 steps. And then the calculator gave us the final answer. Okay, so on the test on Friday, I told you you're going to have 3 law of sines problems, and I'll give you 3 law of cosines. Now, there's only 2 types for law of cosines, so I will repeat one of them. So maybe I'll give you a single side and 2 sides. Okay, something like that. Any questions on that? Okay. So homework, just those 6, 9, 11, 13, 17, 25, 27. Okay. Tomorrow is a review day. Right? So if you have any questions, perfect time to ask me. Make anything up, it's also a good time. I will be after school tomorrow till probably about 3:30 if you need to come after school.